Hello everyone. Let's take a look at our next problem. Two trains starting 30 kilometers apart and traveling towards each other. They meet after 20 minutes. If the faster train chases the slower train, starting 30 kilometers apart, they meet after 50 minutes. How fast are the trains moving? Okay, so the first thing that comes to mind here is it's going to be really useful to set up a coordinate system and define parameters, and then we're just going to write down some mathematical expressions which correspond to each of the statements here. And we're probably just going to end up solving for a couple of variables. So two trains are 30 kilometers apart. I will simply call that distance L. And they travel towards each other. We'll say that the speeds of the two trains are V1 and V2. And we'll use the convention that V2 is greater than V1. This will be important, I think, when it comes down to one train chasing the other. The direction they travel is going to depend on V2 being greater than V1 or less than V1. Okay, so let's say then V2 is greater than V1. We'll say that this is the position of train 2 here, and the position of train 1 is here. So in the first part of the problem, they are traveling towards each other. In the second part of the problem, they're both traveling in this direction. Okay, so the first statement given is that they meet after 20 minutes. So how do I want to write this down? So the distance traveled by, let's say when they travel towards each other, they meet in time t1. And t2 will be the time to meet when train 2 chases train 1. Okay, so the first, if we want to sort of codify the first statement, that when they travel towards each other, they meet in time t1, the distance traveled by each train is the speed times the time. So distance traveled Okay, so when they're traveling towards each other, this is the distance traveled by train 1, this is the distance traveled by train 2, and because they meet somewhere in between, the total distance, or the sum of the two distances between them, is L. So this gives us, L and T1 are both given, V1 and V2 are unknown. Now let's look at the second statement. If the faster train chases the slower train, they still start a distance of L apart. They meet after 50 minutes. Okay. So how are we going to write this down? So they meet somewhere out here. In fact, they're probably going to meet, to make it obvious, they meet pretty far away. Let's say that, let's just call this M, the point where they meet. L is the initial distance between them, and we'll say D is the distance from train 1 starting point to this new meeting point. So what we have now, the total distance traveled by train 2 is V2 times T2, and this is equal to L plus D, right? Total distance that train 2 travels is L plus D, and the distance it travels is equal to its speed times the time of travel. And the distance the distance that train 1 travels is v1 times t2, and that's equal to d. Right? Train 1 goes from here, ends up there. And now we see we have enough to solve this problem, because I'm going to substitute v1 times t2 into here for d. So I have v2 t2 minus v1 t2 is equal to L. And I now have two equations with two unknowns. Okay, so what have I got here? v1 plus v2 is equal to L over t1. And v2 minus v1 is equal to L over t2. If I add these together, I have 2v2 is equal to L over t1 plus L over t2. So v2 is equal to t2 plus t1 divided by t1 t2 times L. And well, there isn't really too much sense continuing the rest of the problem. It's all sort of laid out here. Everything on the right hand side is given in the statement of the question numerically, so v2 is solved for, and then we can easily solve for v1 from either of these two equations. So the key in a problem like this, as soon as I see anything related to space and time and positions, it's always nice to, well, drawing a diagram always helps. Setting up a coordinate system, so having well-defined, a well-defined length for everything involved, or a well-defined variable to represent lengths of things involved. Defining parameters or variables in a way that basically just allows us to codify in a mathematical statement everything given in the question. Very often it makes questions like this really straightforward. Just in this case, it just came down to solving a system of linear equations. Thanks for watching.